Today is part 2 of our limited edition 2-part series on concentration, and today specifically we're talking about molar concentration. And as you can read, molar concentration is the standard unit of concentration in chemistry because everything works according to numbers of moles. So by definition, obviously number of moles, but also it's going to be in 1 liter of solution. The formula is that concentration is number of moles over volume, where I'm taking just the description I had, the definition I had, turning that into a math formula, and then I can also turn that into a triangle where I can pull the other versions of the formula out from that. And I'll show you a couple of examples as we go. An older term for this is molarity, and I know I mentioned this in the last video that older people, it used to be called molarity, were more familiar with that. Yes, I know I said that, but I also know that some of you didn't watch that video, so there you go. I don't use the term molarity as much now as I used to. I'm kind of made the conversion. Amount concentration is another term you'll see. It's actually a bit more modern of a term, but it's also less descriptive, so I prefer molar concentration. That's just me, but understand amount concentration can also be used. Diving right into examples, if I'm trying to find the concentration and I know the volume and I know the number of moles, I'm just going to put that into my formula where concentration is the number of moles over the volume, and it's just as easy as that. It's just that. Now, the one twist to this is that I will rarely have volumes in liters. Most often our volumes are going to be smaller quantities and they'll be milliliters, so I'll have to deal with that. So here I'm looking for how many moles of solute are in 650 milliliters at 0.55 moles per liter. Well, I'm using the same basic formula, except now I'm solving for a number of moles, trying to find n, so I cover up my n corner and I'm left with volume times concentration. I will first have to convert the volume into liters, where you don't have to write it out exactly like this. In fact, you don't have to write it out like that at all, but I'm going to divide my milliliters by 1,000 to get my volume in liters. Then I could use that formula, so my volume times concentration, the liters will cancel out, one on the top, one on the bottom, leaving me with 0.35 moles. If I carry that thing on, rarely are my solutes going to be measurable in moles directly. I'm going to have to do something else. So we found out last time that a lot of solutes are solids, so masses make the most sense. Well, if I'm trying to find the concentration of a solution, there's a couple of ways we can go about this. I'm going to start by trying to answer the question as best I can. I'm looking for a concentration, so I use my concentration formula. I have a volume, but I don't have a number of moles. Well, if I don't have a number of moles, I'm going to have to go find a number of moles. I have a mass. Well, once I have a mass and a formula gives me a molar mass, then I can find the number of moles using mass divided by molar mass, and that will give me the number of moles. By the way, really encourage you to push the buttons on this one. Really encourage you also to make sure that you know where the that 85 grams per mole comes from. It's just more helpful rather than just simply writing it down. And even worse would be not writing it down, just observing. Anyway, now that I have my number of moles, I can go back to my original formula of number of moles divided by volume. Yes, I had to convert my 350 milliliters into liters, the same way I did last time, and I end up with a concentration. But it's not much more difficult than anything else we've done. It's just making sure that the units work. Okay, I can also work it the other way around, where if you want to make a solution of a particular concentration and a particular volume, and you need to figure out how much solute to use, what mass, I'm going to start with exactly the same approach. I'm going to try and solve for mass. The problem is I have a chemical formula, so I can get molar mass. I don't have a number of moles. So then I go to my other one formula, because now I'm working with a solution as well. I've got a volume, I have a concentration. So I'm going to approach it using number of moles as volume times concentration, trying to be able to solve my original formula. Now I've got volume and I've got a concentration, and I'm going to find the number of moles. I'm going to use that multiplied by the molar mass to get the mass of the solute that I need to have. By the way, if you can look at that question and say, first I need to find the number of moles from the solution, and then I need to find the mass from number of moles in molar mass, that is totally fine. I'm approaching this as trying to solve the answer the question that I've been given and getting stuck and then getting unstuck. But it's a strategy that I'm using that's not required for you to be using unless you get stuck. Really recommend it if you get stuck. Okay, if I have a solution and I add water to it and then I have a more dilute solution, if I add water, I'm going to have more volume but less concentration. I also want to point out the wording of this question compared to how it might also be worded. This says is diluted to 750 milliliters. It could be that a certain amount of water is added. So if I were to add 100 milliliters to my 35, my total final volume would be 135 milliliters. Okay, so just make sure we're reading the question, that you don't just instantly recognize something as a dilution and dive into an answer before you know particular nuances, I guess. Okay, I'm dealing with concentration, but I'm also dealing with the solution, so I'm really just going to be working with this formula. I'm going to do it one way now, and I'll show you another way another time. But the number one thing to remember is that the only thing I'm doing is changing the solvent. The moles of solute are staying the same. Number of moles of solute before stayed the same. The volume of solution goes up, the concentration goes down, because all I'm doing is adding water. I'm not adding solute to this. So that means that the number of moles before equals the number of moles after the first and the second scenario. And what that means is I can take the volume times the concentration of the first group, first scenario, the 35 and the 1.6 moles per liter, and I can figure out the number of moles for that, which is exactly what I'm going to do. That number of moles is going to stay the same. That number of moles is going to be present in the final one as well. So now when I go to my next piece where I'm looking for the concentration, I need number of moles divided by the volume. Now you'll notice I've got N1 and N2 and C1 and C2 and that's mostly just labeling to keep track of what I'm working with. And also, like I said before, the number of moles is constant. I don't really need a number N1 or an N2 here. It could just be N. Really what you want to do is keep track of which one is which, because the biggest mistake that's going to be made is getting the pairs mixed up. So 35 milliliters has to go with 1.6. If I get those turned around, it's all going to go badly. Okay, that's really all there is to it. There's not much more we can do. We can bring in the solutions, we can bring in the masses, but other than that, it's just keeping track of units. And really, that's the biggest thing to do, is make sure that the units work, because I can play with the units on the volumes, I can play with the units with masses and things like that. Anyhow, we'll see you another time.